Hello everybody, welcome back to Polymath, and today we're asking a really interesting question. Do you have free will? And it seems at first, I think to everyone when they're asked this question, I say when they're asked this question as if this is like a daily occurrence in your life, but if most people were to be asked this question, they would answer yes, because it seems quite self-evident that we do have free will, because you have this ability, I don't know why I said it like that, you have this ability to subjectively choose a course of action. So if you took person X, for example, let's say your mate, right? You might know your mate really, really well. You might be able to predict what he's going to do in any given situation, but you'd probably think intuitively, you can't deduce that with absolute certainty. You can't determine in advance what he's going to do. You can only guess, because that person, your mate, or person X in this hypothetical example, still has free will to choose whichever course of action they desire. There's this kind of element of almost randomness that can't be predicted, that free will adds to the equation of behavior. People can choose what they want to do. But actually, if you sort of examine this doesn't really make sense. It doesn't really stand up to much scrutiny because, and this is something that philosophy has studied for hundreds of years, and this guy called Schopenhauer, this philosopher in the 1800s, puts the issue really nicely. A man can surely do what he wills to do, but cannot determine what he wills, which basically means you are free to do what you want. You can choose your own course of action. However, you're not free to want what you want. So let's say you want an ice cream. You go and decide to get an ice cream. You make that free decision to go get an ice cream. Except, is that a free decision? Because the desire to go get the ice cream didn't come from you consciously. It came from your brain, unconsciously. It was this desire that entered your conscious attention, but your consciousness wasn't the first cause here. It wasn't that desire did not originate from your conscious intention. It merely entered your conscious intention. But that means, because it entered there from somewhere else, the desire to go and do that will, that desire, came from somewhere else. It was caused by something unconscious. Let's say in another situation, you're thinking, do I get an ice cream? And then you decide not to. You override that desire. Well, you might think, well, this is an example of free will, because I have this desire that's come from my unconscious and has erupted onto my conscious attention, but I've overridden it. Except the desire to override it has also come from your unconscious. The desire to override impulses and urges, essentially any kind of decision you make erupts onto your conscious attention, it enters it, but it's not ultimately caused by that conscious attention. And you'll notice that I'm using the word consciousness a lot, and free will and the topic of consciousness really do go hand in hand, because it seems like you need to have consciousness to have free will. You need to have some kind of inner fill. You can't just be a robot or an algorithm. It seems as if an AI, for example, so ChatGPT cannot have free will because ChatGPT doesn't have consciousness. It's programmed according to certain principles. It has an algorithm to determine its behavior, i.e. the things that it does and says, and it follows that algorithm. It does not have the ability to reflect on that and break these kind of programming constraints. So consciousness, by the way, is an extremely complicated topic within itself, and it's something that I'm going to talk about on this channel. I'm actually planning like a 3-part series on consciousness because it's just such a massive, crazy problem that it's not just like a scientific dilemma, it seems to really rattle the fundamentals of what we know about reality, but more on that later. The point is, it seems like an AI, so ChatGPT doesn't have free will because its desires don't come from any kind of conscious deliberation, but rather the kind of unconscious programming. Except, you could argue that human brains have this exact same thing as well. Human brains, we have unconscious desires that are generated somewhere in our brain by programming that occurs in the dark, and we just act on these unconscious desires, as we see in the example of the ice cream. So, again, it seems like we can use our self-awareness to reflect on the desires that we have and then decide to go for them or not go for them, but that decision itself comes from unconscious processes. So, there's this really famous example. So there's this guy called Leibniz, this kind of philosopher and scientist who was a contemporary of Newton, and he came up with the idea of Leibniz's mill, which is basically, it's just this metaphor saying that, so a mill is a machine in this scenario. Imagine if the human brain were a massive machine, and you walked around in this machine, right? There'd be no signs of consciousness, or in this example, free will. You'd just see different parts acting on each other. So if you were somehow able to shrink to the size of a nanometer and enter the human brain, you wouldn't see any kind of anything that was consciousness or was free will, because these are intangible things. There's no free will substance. I mean, That is potentially a belief that some people may have, but scientifically, anyway, there's nothing that physically, tangibly corresponds to that. If we enter the brain, we see neurons firing, we see neurotransmitters moving about, we see activity going on in cells, we see all this physiology going on, we see all this neurobiology. But there's no kind of, when someone makes a decision, there's no kind of inexplicable rush of like some kind of fundamental supernatural substance that appears. It's all just the same basic mechanisms of the mind. So the belief actually that the human mind can be sort of reduced to this description of different moving parts all acting on each other is called functionalism. And functionalism is controversial. So for example, in the study of consciousness seems to prove to be like some kind of really big problem that we can't square, because consciousness, again, doesn't seem to be the functionalist view of the brain doesn't really explain how consciousness comes about. It doesn't really explain why all this information processing, why all these different moving parts and different parts of the brain communicating with each other, why that has any kind of inner feel or subjective experience. It doesn't really explain why all this happens in the dark. But the fact still remains that when we look at something like free will, and we say it comes from the unconscious process of the human brain, it does seem to be generated from exactly this place, being generated from in the dark. It just sort of comes from these different parts of the brain moving on each other, generating whatever unconscious desires we may have, and then we act on those desires and make a decision. But that process of decision making, our consciousness isn't actually the first cause of that decision. Our consciousness does not bring about that decision. It merely makes us aware of that decision. And again, I'm saying that as if it's a fact, as if it's an absolute. This is a massive, massive debate in both science and philosophy. It's not an absolute. I'm just arguing the contrary position because I want to make you guys think a little bit about free will. So, the kind of activities of our brain, there's no ghost in the machine when we look at the brain on like a low down level. If we were to shrink down to the size of a nanometer and travel around the brain, there's no supernatural force animating this. There's no kind of big bang of a free decision. There's no ghost in the machine that somehow enables us to have free will. It's just parts moving on each other. That is, in any case, the neurobiological view. So an AI, for example, doesn't have free will because its cognition is also mechanistic. So what I've just described is a mechanistic view of the brain, as if a giant machine of different parts acting on each other. Now an AI doesn't have free will because, again, its cognition occurs according to the same processes. But what about animals? It gets a little bit muddy when you think about that. Does a cat have free will? Or is a cat just acting on its impulses and its urges? Are the decisions that a cat makes just decided by different activity in different parts of its brain, encouraging it to pursue, kind of making it really pursue certain courses of action? Because even if that cat, you could also argue, even if that cat has the capacity for self-awareness, does that self-awareness actually do anything when it comes to the decision making, when it comes to the free will? And if we kind of extend this animal metaphor further, does a bird have free will? Does a worm have free will? Does an amoeba have free will? At what level of sophistication in life and consciousness is free will even likely to emerge? And although, of course, as I mentioned before, it's not necessarily the case that just because we are conscious, we have free will. So in fact, one of the kind of viewpoints on conscious and where consciousness comes from, what it's all about, and we're going to be exploring that more later in the episode specifically about consciousness. One of the viewpoints is this belief system called epiphenomenalism. And it basically says that consciousness, so subjective experience, so feeling things, for example, rather than just processing information. So I'll give an example of that, by the way. You can use neurobiology to explain everything about how pain works. We can learn everything about what neurons are involved, what neurotransmitters are involved, what circuits are involved, what parts of the brain are involved. But learning all that information doesn't tell you anything about the subjective experience of being in pain. So another example, which was actually formulated by this guy called Jackson, who is the same guy who puts forward the view of epiphenomenalism, Jesus, is the example of this fictitious person, this hypothetical person called Mary the neuroscientist. And Mary the neuroscientist is someone who's raised in a black and white house with only access to black and white media, and she reads all about the color red and what it makes people feel and what it connotes and the neurobiology of it and what kind of wavelengths of light are involved. But then she goes outside for the house for the first time and sees the color red. And the question that Jackson asks is Mary having a new experience? Is she learning something new here? Because if she is learning something new, It means that neurobiology and mechanistic descriptions of how the brain works don't tell us anything about what subjective experience is actually like. That seems like a bit of a tangent, but free will and consciousness are so intertwined. I just feel like it's a good example to use. But anyway, the point is, in epiphenomenalism, the belief system is that subjective experiences are generated as a consequence of physical processes. They're generated because of all these firings in the brain. But it's sort of like imagine a massive machine, and there's just this cog at the very edge of the machine that happens to be spun by all the workings of this machine. And this cog is what leads to subjective experiences. It's what leads to us feeling things like happiness and seeing things like color and feeling things like pain. However, these conscious experiences, this subjective experience, doesn't actually affect our decision making. It's again just a cog on the end of the machine. These unconscious neural processes that are happening kind of outside the realm of subjective experiences and which are subject to mechanistic explanations, these are what determine what we actually do and the decisions that we make. Our consciousness is just sort of a side effect of this. It's something that makes us aware of the decisions that we make and which gives us the illusion of the decisions that we make being free and based on us and our consciousness. But in actuality, that consciousness, it's just an illusion. It's just this kind of mistaken belief that our consciousness is the first cause, the kind of original root cause of our decisions, when in reality, it's just a side effect. Now, epiphenomenalism is controversial, and we're going to be exploring that more when we look at consciousness later, but it's just something that I think is interesting to bring up. So, there was this other guy called Laplace, and Laplace was a mathematician in, I believe, the 1800s. And Laplace basically thought, if you could understand the laws of exactly why stuff happens, you can predict the future. So an example is, sorry for just messing with my hair, I'm not narcissistic, I promise. It's just kind of like tickling my eye, and I'm very ticklish. And the hair is sort of starting to, it's intruding on my consciousness. But the question is whether that decision to move my hair was free will, or whether that was always going to happen anyway, and that my conscious awareness of my decision to move the hair out of my eyes is just a side effect of these unconscious neural processes. Anyway, so Laplace basically used the example of astronomy and basically said, listen, we know all the rules, we know many of the laws of astronomy. We know why the planets move in the way they do. We know how they move. We know the patterns of them moving. And as a result, we can predict exactly when a solar eclipse is going to happen, right? So the idea is that the rules of astronomy are deterministic. We can determine the future by understanding the laws of how things work. And then he proposed this kind of godlike being, and he called it a demon. The fact that he called it a demon is just a sort of artifact of the terminology that he was using. But the point is, imagine you have this godlike being, and this godlike being knew everything about your neurobiology. They knew everything about how the neurons work. They knew about everything about what made neuron X fire and when did neuron X fire with neuron Y, which regions of the brain are going to be active at which particular time, which neurotransmitters will be where, exactly which particle of whatever will be at any given place at any given time. Imagine you have this godlike being, this omniscient being with all of this knowledge, and therefore the ability to understand where neurons would be and where particles would be in the future. Would that being be able to perfectly predict exactly what you would do at any given time by just simply knowing all the rules of you and how you work? Because if so, then you don't really have free will, because you're just following, well, arguably, anyway. You can argue that you don't truly have free will because you're just following unconscious patterns in your brain, and your conscious awareness of that doesn't determine the course of action. The rules of neurobiology determine the course of action. So that viewpoint, by the way, this belief that individual action can be predicted in advance if the rules are known, is called determinism. And it's a really important kind of stance in this whole philosophical and scientific debate on free will. So, a guy called Benjamin Libet was a neuroscientist. In like the 80s and the 90s, he actually did an experiment on this. He wanted to kind of experimentally get some evidence on the deterministic position. And as a result, he did some experiments with an EEG. And an EEG is a device called an electroencephalogram. And it basically is a way of just sort of mapping the electrical activity of the brain. Because as I've said, the activity of the brain is just electricity firing through neurons. It's electricity firing through meat. But that electricity is what animates it. If there were no when we say neural firings, I don't mean that each brain cell is literally combusting. I mean, little jolts of electricity are coming from that neuron and communicating with other neurons. And this kind of passage of electricity, this electrical action through the brain, is what generates life and consciousness and action, which in itself is fascinating. It's amazing. And again, this whole question of consciousness is all about, how does this happen? Like, how the hell does that physical process give rise to the feelings of pain and happiness, etc., etc., etc. So when you look at the data of an EEG, so an EEG just gives you lots of little like traces, lots of little like lines on a graph, basically. And the data of an EEG consists of these things called event-related potentials, ERP. And an ERP is basically it's sort of just a pattern of electrical activity in the brain. And there's lots of different ERPs and different ERPs, lots of different names. And there's sort of they're discrete electrophysiological markers of discrete events. So there's an ERP for moving, there's an ERP for surprise, there's an ERP for happiness, there's an ERP for just receiving sound. It's this sort of signature of your brain doing something, basically. So Libet was interested in a particular kind of ERP, and it's an ERP called the readiness potential. And it builds up over the part of the brain responsible for moving, the motor cortex. I talk a little bit more about neuroanatomy in this other podcast that I did called Understanding Happiness, Science, and the Buddha. I think I'm going to make another polymath episode about neuroanatomy at some point, just to clear things up. And what happens is, this sort of, just before we make a voluntary action, so just before you choose to move your arm, for example, this pattern of electricity, this readiness potential, this ERP builds up over the motor cortex, and we can measure that. So that's essentially what Libet did. He measured that using electrodes. So he showed people this thing called an oscilloscope clock. And it's basically like this clock, right? But instead of hands, you have this dot that just sort of goes from second to second to second around the clock. So that's an oscilloscope clock. You see the dot go round and round and round and round. And basically, Libet then played an individual. So Libet found that you could, let's say, for example, you played a research participant a sound. And that participant would then say, okay, when I heard this sound, the dot was at position 10, or at position 15, or position 30, or position 45, or position 60, etc., etc., etc. So what Libet did was he told his research participants, flex your wrist whenever you want. So whenever you get the urge to, just move your wrist. And when you do move your wrist, tell us where on the oscilloscope clock that dot was. And individuals basically said, but about 200 milliseconds before they freely decided to act, they had the conscious desire to act. So what I'm trying to say is that for each participant who did this experiment, they had the conscious decision to move their wrist, they decided to freely do that, and then 200 milliseconds later, their wrist moved. However, Libet basically found that readiness potential, that ERP that we were talking about, built up 550 milliseconds before their wrist actually moved. So what happened is, the readiness potential for movement built up before subjects reported that they made the conscious decision to move. So what that potentially means is that before the subject had the conscious decision to move, there was already electrical activity in the brain that was getting them ready to move. So this is a really, really surprising finding, because again, most people assume that the conscious decision to act is the sort of first mover. In this causal sequence of what determines an action, your conscious decision to do so is the first part of that sequence. But actually, the reality which seemed to be revealed by Libet's experiment was that what actually came first was this unconscious neurological initiation of an action, then the conscious decision to make that action, and then that action. Now, this is a really, really big deal, but Libet's study had a few sort of limitations. So a big thing is that it only really looked at one part of the brain. So it looked at a part of the brain called the supplementary motor area. Sorry, I was actually right, I was just second guessing myself. The supplementary motor area. So that's where specifically where this readiness potential built up. So we didn't know what was happening in other parts of the brain. And also, so the SMA is only responsible for the sort of last stages of planning an action. So when we're planning an action, actually different areas in the brain are involved in that. And the SMA is just this sort of last part of the brain that's responsible for this big causal chain. So when I said earlier about how like the unconscious parts of the brain initiates an action, and that's the first mover in this causal sequence, actually that begs the question, well, where in the brain is initiating this conscious action? So the SMA isn't actually the sort of really the first mover. It's involved in the last stages of planning. And as a result, you only get this time frame of like a few hundred milliseconds. So the limit found, for example, that 350 milliseconds before they weren't being shot, subjects planned a conscious action, there was that readiness potential that built up. But that's actually a very small time frame. And you can sort of argue, and a lot of people did argue, well, there could have just been like a measurement error. Because actually it's really difficult just measuring stuff within a few hundred milliseconds. So all this potentially massive thing that you've just found could be explainable just by that. And finally, we don't know whether that activity that we found, that readiness potential in the supplementary motor area, the SMA, we don't know whether that was specifically encoding for that specific decision to move, or whether that's just like a general readiness to act. Because it could be the case that the SMA, that readiness potential, just shows like a general sort of, you're just sort of ready to act. But whether you decide to actually act is up to you, and you have free will to do that. So there's lots of questions sort of raised by that because of these limitations. Now, Libet himself, actually, you might expect Libet as a result of this experiment to be some kind of arch determinist, but actually he proposed that we do still have free will. But that free will is in the form of a free won't, whereas we have the ability to veto an action. So Libet thought we had this readiness potential that bubbled up in our heads. We had this sort of tendency to action which bubbled up in our heads, but whether we could consciously veto doing that action. So we still had free will. But that still doesn't really make sense, because then that really begs the question of where is this free won't coming from? Where is this conscious veto coming from? Because it's not the case that all this stuff about free will and readiness potentials is all explainable by neurobiology and mechanistic explanations of the human brain, and suddenly we just have this inexplicable quasi-supernatural veto. We have this kind of mystical power of free won't that manifests itself in our brain. Like, that has to come from somewhere. Our decision to veto an action is still a decision. So it's not a sort of watertight argument. So another experiment that was done. And there was another experiment done by this group of researchers led by Chun Soon and his team of 3 other people. I don't remember all their names, unfortunately, but I really recommend you go and look it up. So this was an article published in 2008, and Soon wanted to design an experiment which would remedy these limitations. So Soon's experiment was sort of similar than Libet's, but it used a different kind of machine. So instead of using the device of an EEG, it used an fMRI. You might have heard this. So fMRI, functional MRI scanning, is basically when you hook someone up to this little machine, and what happens, well, actually it's quite a big machine, but that's not really the point. The size doesn't matter when it comes to electrical machines. Don't quote me on that. The fMRI basically, it just measures which part of your brain are active at once. So for example, you can put someone on an fMRI scanner and you can give them a crossword puzzle, and then you can see which parts of their brain become more active, i.e., so what it's technically measuring is which parts of the brain use more glucose, but that's a proxy of like which neurons are active, which neurons are firing and need energy. So it basically shows you which parts of the brain are active when a person is doing a specific action. The idea being it shows you which parts of the brain are responsible for that action taking place. So on an fMRI, when people describe fMRIs, they usually say like, oh, what happened in fMRI is like this area of the brain lit up. That lighting up is just because on the computer display for an fMRI, the color is displayed as brighter, the more active a region is. So what Soon did is he hooks people up to an fMRI, and he gave them 4 buttons to press, 2 on the left and 2 on the right. And he also showed them there was a screen in front of them. And on this screen was just a stream of letters. So every 500 milliseconds, a new letter just showed up on the screen. And subjects were basically told, at any point you choose, you can press either the left button or the right button. Just press, you can choose. There's that decision. You have the decision, left versus right. And once you do, so once they press that button, they were shown this other screen with 4 letters. And they're basically told, okay, when you made that decision to press left or right, which letter was on the screen at that time? So that was kind of a way of localizing at which point did participants consciously make a decision. And at the same time participants were doing this, they were in an fMRI scanner. So the researchers could sort of see which areas of the brain were active when they were making this decision. And the fMRI updates every 2 seconds. So participants genuinely reported that about 1,000 milliseconds, so 1 second, before they made a decision, 1 second before they decided to press left or right, they made that conscious decision. But here's the fascinating thing. By analyzing the activity in the brain, Soon et al., so this team of researchers, was able to predict with greater accuracy than chance, so with an accuracy that was above 50%. So what that basically means is that so 1 millisecond, for example, 1 millisecond before a participant chose left or right, the team of researchers could look at their brain and determine with 100% accuracy which button they were going to press. However, 10 seconds in advance of the subject making the conscious decision to press left or right, the researchers could predict with greater than a 50-50% chance, so greater than just random chance, greater than just 50-50 coin toss, they were able to predict with above 50% accuracy whether the subject would press left or right, which is massive, because we're not just talking about a few hundred milliseconds anymore. Because when we kind of think of the present moment for most people, you might sort of see as a second. The width of now, the present, maybe is a second, a couple seconds. But 10 seconds is definitively in the past. So this really, really raises some crazy questions about free will. And what they basically did to determine this was they looked at a region of the brain. So they found that this region of the brain called the frontopolar cortex, which is this area in the brain, it's part of the prefrontal cortex. And the prefrontal cortex is really the part of the brain that makes human beings human. So the prefrontal cortex is responsible for decision making, executive control, planning, rationality. The frontopolar cortex is a region of that prefrontal cortex. And they found that the frontopolar cortex could be used, was the sort of brain region that predicted 10 seconds in advance whether a subject would press left or right. And they could basically analyze the activity in the frontopolar cortex to determine whether it was going to be left or right. And by sort of looking at the supplementary motor cortex, the SMA that I talked about earlier, the supplementary motor area, and another brain area in the motor cortex called the pre-SMA, the pre-supplementary motor cortex, the researchers could figure out 5 seconds ahead of time exactly when a subject was going to press the button. So the prediction of the timing of the decision was 5 seconds in advance of it consciously being made, and the prediction of the decision itself was about 10 seconds in advance of the decision consciously being made. So again, this potentially has massive philosophical implications for free will. The fact that can be deduced in advance. And it also showed, what was really interesting, it showed that when we look at the unconscious mechanisms of the brain and where decisions come from the brain, where in the brain are these decisions bubbling up, it sort of suggests that the prime mover, the first cause of our decisions, the ultimate unconscious origin of our decision, is this region of the brain called the frontopolar cortex, which sort of fits in with what we already know about this brain region as being really involved in decision making and executive control. So, because again, the frontopolar cortex, I think, is near the very front of the prefrontal cortex. And when we look at the frontal lobe, the more sort of sophisticated human rational parts of that tend to be a little bit further forward. It evolved later. So towards the back of the frontal lobe, we have the stuff responsible for movement. So a lot of the motor cortex is in the sort of back region of our frontal lobe. And as we get more to the front of our frontal lobe, we get the prefrontal cortex. And the frontopolar cortex is around about the very front of our brain. So this has massive philosophical implications. It's not necessarily the case that it proves the determinist position, because there's still some limitations. So it's in a laboratory. It's not really simulating a real life decision, like for example, whether to go get an ice cream or not. It's also just a binary choice, left or right. And also fundamentally, it's not necessarily the case that just because brain activity can be used to predict what someone's conscious decision will be, that completely erases the role of free will. There might be some kind of conceptual framework in which we can square this seeming contradiction of free will with the fact that conscious decision can be predicted in advance by looking at brain activity. That doesn't necessarily prove the determinist position. Just because so Libet also points this out. Determinism is really great for things like astronomy and physics, but there's no reason to assume a priori. So there's no reason to assume ahead of time, automatically, that determinism also applies to psychology and philosophy. So just because determinism works in some academic disciplines doesn't mean it's going to work in all academic disciplines. Is basically the point that Libet was making. So I'm going to just give another sort of viewpoint on the idea of free will being an illusion. I'm just going to try and explain it a bit more using the parlance of this other scientist called Wegener, who wrote in this paper in 2003 about the mind's best trick. And Wegener says the mind's best trick is free will itself. So Wegener is a determinist. And again, I'm not saying in this video that determinism is correct. I'm trying to give a balanced perspective, but I'm talking a lot about the determinist viewpoint and the experiments in support of that, because I want to make you guys think. I want to sort of, because it seems intuitively obvious to us that we do have free will. So I just want to sort of encourage a bit of like deep thought. I want to give you guys a bit of I was about to say mind F word, but I shouldn't swear. I should try and make, I've decided I should try and make these non-explicit. I should try and stop myself from swearing. So fine, I won't swear. A bit of a mind screw, I guess. Ugh, feels kind of gross, like, not gross, it feels kind of cringy, like censoring swear words in like weird novel ways. But you get the point. I'm just trying to make you guys think, essentially. So Wegener basically says, we have, actually, I'm going to show you this diagram, right? It might be reversed for you guys. Yeah, it will be reversed for you guys. Ugh, that's really annoying. So Wegener basically says, we have a conscious thought and we have a conscious action. And it seems as if the conscious thought causes the conscious action. But in reality, that thought was caused by an unconscious cause of our thought. So it's as if, it's what Schopenhauer was saying earlier. You may have the desire to go get an ice cream, but that desire is only in your consciousness for reasons that you can't control. You can't control your desires and what you want. So there is an unconscious cause of that thought. And the actual causal path travels from unconscious cause of thought to thought. Also, there's an unconscious cause of your action, so what you actually decide to do, and that there's an actual causal, the real causal path between, sort of leads between unconscious cause of action and action. And then there's another unconscious path, there's another unconscious connection between the unconscious cause of thought and the unconscious cause of action. So Wegener also argues free will is an illusion, but he argues that this illusion is sometimes more compelling than others. There are certain circumstances, there are certain principles that make it more likely that we'll ascribe free will to something. And these principles, as Wegener calls them, are priority, consistency, and exclusivity. So basically, we infer causation based on events happening successfully. So let's say you're playing pool, right? And you whack the white ball and an orange ball and it moves, right? So we infer causation based on that. We infer, like, for example, the black ball hit the yellow ball. Sorry, the white ball hit the yellow ball. I do know how to play pool. I'm actually really terrible at pool, but I do know how to play it. I just tripped over my words there. The black ball hits the yellow ball, and oh, Jesus Christ. The white ball hits the yellow ball, and that causes the yellow ball to move. But in actuality, you could, for example, have some kind of theoretical experiment where there was someone underneath the table controlling the balls remotely. We know how physics works, so we know that energy is being transferred from the white ball to the yellow ball. But we're really, because we're inferring causation really, even though we don't need to think about the physics of it to just infer that white ball causes the yellow ball to move, because these two events happen successfully. And that's an actual effect. So there's an effect which is noted in psychology called the launching effect, which is basically based on this principle. Just because A happens and then B happens, there's this sort of unconscious cognitive shortcut that we make about A causing B. We infer that causation even when it isn't proven. So I talk a lot more about like cognitive shortcuts and the inherent irrationality of the human brain and human cognition a lot in previous episodes. There's a lot of that in episode 15, for example. But anyway, principle 2, consistency. Wegener says the illusion of free will is strongest when the thought is consistent with the action. So when we think of something and then we do it, the two things are consistent. However, when thoughts are inconsistent with actions, so for example, a Ouija board, when you move a Ouija board, you're doing an action, but you're not consciously thinking about doing that action. There seems to be some kind of disconnect between what you're thinking and what you're doing. Another example of that is alien hand syndrome, where individuals report their hand, for example, moving entirely of its own seeming free will. They have no conscious control over what their hand does. It acts independently of their own thoughts. And in these kind of situations, when thought is inconsistent with action, we tend not to ascribe free will. So for example, people with alien hand syndrome say that alien hand has a mind of its own and has its own free will, and they don't have the ability to control it. And finally, principle 3 is exclusivity. So the illusion of free will kind of dissolves when we can attribute our actions to other plausible causes. So for example, let's say you get hypnotized and a hypnotist says do something and then you do it. because you can attribute your action to that cause, rather than any cause that's happening inside your own head, the illusion of free will seems to break down. So Wegener basically says these three things, priority, consistency, and exclusivity, kind of determine the strength of this illusion of free will, but that it is just that, an illusion. And again, some people may disagree with that, some people may not. I'm just presenting that view to you. So another thing that I sort of wanted to talk about, is sort of a way to bring all this into focus, to sort of talk about the practical implications of all this, is this guy called Charles Whitman. So on August 1st, 1966, Charles Whitman massacred a bunch of people. So he killed his mum, he killed his wife, and he killed 14 other people. However, before he did that, he was complaining of having lots of headaches, lots of altered mental states, kind of weird, kind of almost an altered form of consciousness in the sort of weeks and the days leading up to the killings. And he basically left a note saying, listen, I know something is wrong. And he said, after my death, I wish that an autopsy would be performed on me to see if there is any visible physical disorder. And in fact, there was. So Whitman was found to have something called a glioblastoma. It's this kind of brain tumor. And it was basically pressing against regions of the brain that are responsible for regulating strong emotions and causing inhibition. So that kind of suggests a bit of diminished responsibility, right? We might feel a little bit less hateful towards this guy because there seems to be like a mitigating factor. But then the question is this person responsible for their actions? The question is then, if we look at a less obvious examples, let's say we look at psychopathy. So let's say, psychopathy it's actually a subdivision of a wider disorder called antisocial personality disorder. But I think I'm going to do another polymath episode on that at some point. So in psychopathy, you have the biological inability to feel empathy. You don't feel other people's pain. You also have the inability to feel guilt or remorse. Now, those capacities can lead to psychopaths doing awful things, not just violent crimes, but just casual, everyday lying, manipulation, hurting people, using people, etc., etc., etc. But then you get into the argument of free will, wherein it's like, if you do something which is the direct result of not feeling other people's pain and not feeling guilt, how responsible are you for that action? Now, in the case of a psychopath, you can still say that as a psychopath, although you might not feel empathy or feel guilt, you can still cognitively understand that your actions have consequences and that suffering is a thing which most people experience. So I personally don't believe that the neurobiology defense is suitable to diminish culpability of crimes for psychopaths, but you might find that it's a mitigating factor. So you may personally think, if you were a jury member, you would believe that certain biological incapacities should be mitigating factors for antisocial actions. But then, where does that line draw? Because if we argue that no one has free will, we can say that any kind of everyday murderer or domestic abuser or misogynist or racist or just bad person or just someone who doesn't care about other people are just following the dictates of their brain chemistry and their brain biology. And indeed, when we look at stuff like empathy, it has a biological basis. When we look at stuff like cognition and being able to consciously understand how other people get hurt, so something called cognitive empathy, that also sort of has a biological basis. So in autism, for example, autistic people are able to have effective empathy. So if they recognize that other people are in distress, they feel that. But many autistic people, and again, autism is a spectrum, there's also different flavors of autism, but you know what I mean. But many autistic people struggle with something called cognitive empathy, which is being able to cognitively understand how someone else is feeling. Now in psychopathy, the deficit is in effective empathy, not in cognitive empathy. But you might be thinking to yourself, well, if someone had a deficit in both cognitive empathy and effective empathy, and they did something really awful, but they didn't even understand that what they did was wrong, and they didn't feel that it was wrong, to what extent are they culpable? So the free will, this kind of thing of free will, it's not just an abstract philosophical contemplation. It has something which has massive consequences for our judiciary system and beliefs on morality. Another example, if you had Stalin's exact genes and exact environment growing up, so if you were you, but you had the exact genetic code of Stalin, your upbringing was the exact same, what you ate was the exact same, what you did was the exact same, the political context was the exact same. If everything was the exact same, would you or would you not grow up to be Stalin? And if you believe that you have if you had Stalin's exact genes and environment, you'd go up and do exactly what he did, are you conceding that human beings don't have free will? Are you conceding that we are in fact merely just tools following the predictates of our genes and environment. Is human decision making like a bus, which is able to move freely on roads, or like a tram, which moves within circumscribed grooves on a road? But these grooves are just sort of our genes and environment. So I'm just checking the time. Now, just as a sort of thing to mention, so this social psychologist called Baumeister, actually it was Baumeister et al. So et al is this abbreviation in science, just basically meaning and others. Actually found that when you took research participants and you told them about determinism, and you sort of encouraged them to believe in determinism, so this group of people who were led to sort of believe less in free will actually reported less inclination to engage in altruistic or pro-social acts. So for example, they reported less inclination to give money to the homeless, or to give people, or to sort of lend someone their phone, is what I'm trying to say. So, and also another experiment showed that individuals who already disbelieved in free will, so who believed in determinism, were actually less likely to offer time to help out the students whose parents had passed away. So this whole stuff on free will and beliefs on free will does actually affect how people think. This has really real implications. This is a really important current moral issue. So it may be actually that the illusion of free will may be an illusion, but it's not something that we want to unlearn. It might be that the illusion of free will is very, very important for morality. So, and again, you might disbelieve that. So another thinker called Susan Blackmore believes not only that the illusion of free will can be unlearned, but that doing so wouldn't cause a kind of moral and judiciary collapse. And that in fact, if we just shifted the focus of punishment from retribution to just things like deterrence and keeping society safe from potentially violent or antisocial people, or rehabilitation, because you can still change people's brain chemistry. You can still change the sort of cost-benefit analysis of doing an action for someone if you provide a deterrent. It's just the case that that cost-benefit ratio is computed subconsciously in people's heads, according to determinists, rather than consciously. Now, you may disagree with Susan Blackmore. I haven't talked about Susan Blackmore here personally because I just didn't feel particularly as if it needed to be discussed here, but I welcome you going and looking that position up. I say I welcome it as if I'm some sort of gatekeeper of knowledge. By all means, if you want to, you should. It's great to do your own research. I'm telling you about Susan Blackmore so that you can go and do your own research if you want. The point that I'm trying to make is just that all this stuff matters. And actually, Baumeister's findings are congruent with other findings which show that if you put pictures of eyes in public spaces, it actually makes people commit less petty crime in those areas. So for example, on subway stations, if you put pictures of eyes on subway stations, just watching people, not actual cameras, just pictures of eyes, it actually makes people sort of less inclined to commit crime. Because again, and I talk about this a lot throughout the series, much of our cognition is not rational. We're not consciously thinking about cost-benefit analyses. We're subject to lots of emotional and social and moral impulses that all impact our decision making. And the stuff like the eyes watching us, rationally and logically, if you think about it, that shouldn't deter you from committing any crime because it's not an actual CCTV camera. I don't know why I said that so weirdly. CCTV camera. I don't know what, yeah, whatever. But the fact that it does, the fact that that effect is actually statistically significant, shows that people's decision making is not entirely the product of rational forces. The whole point of this episode has been to say whether that irrationality is tied into our free will, and whether we have conscious control over it, or whether we don't. And that is today's episode. This is a good length, I think. I was kind of debating whether to make this a Polymath Bites episode, so like a 20-minute episode, or like a full-length episode. I'm happy to make just like a 45 minutes. I feel like we've covered a lot of stuff, and we haven't talked about stuff that we didn't need to talk about. But we've also done it in like a reason. We've been concise. We've talked about a lot of stuff, but we haven't gone too overboard. As I'm really wary of making. I'm not wary. I do enjoy doing it, but I'm just sort of starting to think that making really long videos in the range of 1 to 3 hours, it's not very accessible. And what I really want to do in this podcast is just sort of popularize information that I think is both interesting and useful. And the best way to popularize that is to make something accessible. So anyway, that's my thought process. Is that a free thought process? I don't know, your decision. I hope you all are doing very well. I hope you've enjoyed, and I hope you have a lovely day. Take care. Bye.